Absolutely, yes. And while we're going through that exercise, a little, I suppose, correction on the part of the topic earlier on. It's actually the other way around. So in essence, the part of the conversation I wanted to, and I kind of start off with the introduction here, to go through is the other end of the spectrum, right? So once you know that there is a problem, um, you generally go through this from an APM perspective, and you go through the application performance monitoring stack, and you figure out that the problem is with the database instead of the app stack directly. But where does that leave you, right? So in essence, some of the things that I wanted to talk about in the next 30 minutes was around what you do then, right? So I just thought I'll bring that up. So with that, I kind of made the introduction already. So let me step into the next slide. So the topics that I want to go over in the next roughly 30 minutes is essentially what sort of challenges do we have in observability today? Um, some of the troubleshooting and tracing, and it's a topic I think we're all very familiar with, unfortunately. Looking at some things like tuning query performance and how to get there, and how to make the most out of that. Um, what sort of impact on our overall performance in terms of how our services, applications, and the database itself, um, the infrastructure has, and then kind of like lastly, which is usually the first step in the process, but we're going to get to it last here, is how can we essentially take all of these points and deploy code with greater level of confidence, right? And then we obviously have a Q&A part at the end of this. I'm going to get to the most boring part of the presentation first, and that's the introduction. I think just like everyone else, I don't particularly enjoy talking about myself. But my name is Markus Strauss. I'm one of the product managers at SolarWinds. I'm responsible for the database performance monitoring product, DPM. I've only recently joined SolarWinds, just roughly about 7 months ago. Before that, I've spent quite a number of years at McAfee managing their database security products. And I have had, like so many of us, various stints in other companies over the year. And do feel free to reach out to me on LinkedIn if you want to. And with that, I kind of leave it at that. Like I said, nobody really likes talking about themselves too much. So challenges of observability, and it's a funny one, right? Because we generally try to achieve something without, at least in most cases, having all of the right tools at hand. And that's something that I've painfully experienced myself over the years, and I'm sure everyone else in the audience has too. We generally get to having to achieve some level of observability by means of there is a problem or there is a need for it, right? And very often we do that with not necessarily having the right tools at hand. But one of the things that modern applications have in common is that very often they're pretty difficult to troubleshoot, and that's largely down to several items, right? I mean, we deploy pretty complex distributed architectures these days, and that's good, right? I mean, we want that, we need that. It helps us create better services. It helps us create faster services, better products, better experiences for our end customers. But in the end, it does make it more complex to troubleshoot. In a lot of cases, our workload on the environments that we manage has become quite demanding over the last number of years. And to top it all off, as always, usually we don't have the best instrumentation in place. Uh, Again, I'm going to use my experience there. For me personally, in a lot of cases, instrumentation becomes a topic once something went wrong, right? I mean, we all build apps in general to serve a purpose, right? It's to solve a problem, or it's to serve a specific customer need, or to build a product, or to create an internal service, or something along those lines. We generally don't build applications around all of the different instrumentation needs that we possibly ever could have. And by its extension, then usually when things go south, that's when we realize we probably should have spent a little bit more time on that. But very often that's just the way it is, or we inherit applications from various areas, right? When things go wrong, there's a lot at stake, right? I mean, again, I'm going to use myself as a guinea pig here, right? But I'm old enough to remember when you went onto, let's say, a website, right, and it was perfectly acceptable for it to take 25 seconds, 30 seconds to load the ever dreaded number of GIFs or GIFs, whatever camp you fall into pronouncing that, loaded, and we were all very happy with that. But those times are gone, right? Our end consumers have pretty high standards when it comes to responsiveness and just plainly the thing to work, right? If I install an app on my phone, or if I use an app on my phone and I open the app up and it just doesn't load, or it errors out, or anything like that, in 9 out of 10 cases, if that app isn't absolutely crucial, it's gone, and I'll find a different one that does the same thing, right? And I think we all have had that experience, both on the consumer side as well as the the provider side. So customer experience has become a huge impact, and it impacts our bottom line. Then the inability to really measure workload properly has become a pretty big challenge when it comes to if stuff goes wrong, not being able to know where do I need to throw extra capacity at, or where do I need to spend more money. And especially in a world where it is so easy to spin up more pods or more instances very quickly, the knowledge of understanding where do I need to focus that money is very important, right? It's easy to throw money at the problem, but if I don't throw it at the right area of the problem, then all I'm doing is I'm wasting money. And if I'm not able to really pinpoint and understand where, and excuse me, my voice has been funny all day. If I'm not really understanding where the root cause of the problem is, then, well, we all know how that looks like. Generally, the finger pointing starts, right? We do end up with the, well, that's not our problem, that's their problem. It wasn't our fault, it was their fault, right? So there's quite a lot in terms of challenges that we need to deal with on a daily basis when we start looking at the whole cycle of monitoring the performance of an application, right down from the application stack down to the database layer. And historically, I think it's somewhere around 70% of problems that are performance-based problems within your app stack is traceable back to a problem of sorts within the backend, within the database layer, right? So the two biggest ones out of all of the challenges that we face, and that list was certainly not exhaustive, right? I mean, I'm sure we could all add another 10, 12, 15, 20 challenges that we all face on a day-to-day basis. But the two biggest ones are probably complex architectures and just having poor visibility. And again, complex architecture in itself is not a challenge. Well, it can be, right? But not in our example here. It's something that we want. It's something that we need. It's something that we have to use and build up to provide better services, to provide faster results, to provide a better experience for whatever services that it is that we provide. But we do need to be able to capture workload, not just from the application stack perspective, but also from the database perspective, right? That goes both ways. We need to understand where do we need to focus our energy and our resources in order to understand where the root cause of the problem is. And we also need to be able to correlate all of the individual data points that we collect, whether that's on the app stack or whether that's on the database layer. We need to be able to correlate all of these together into a much bigger, much clearer picture that we can use as the baseline of figuring out whatever problem it is that we need to solve, or whether there is room for improvement. So when I think of troubleshooting and tracing, the first thing that comes to mind is that dreaded phone call at 1 o'clock in the morning, where you pick up the phone and someone yells at you that something broke down. And I think that's probably, in a lot of cases, the experience that most of us have when we think of troubleshooting. It's that dreaded email or phone call that something just simply stopped working, right? And where we need to start looking at from a database perspective, and obviously this conversation is very much database centric. I do keep it product neutral because I'm not here to talk about products, but what we do need to start looking at it from a database level is, what's usual, what's unusual, how do we find outliers? When we look at, again, that threaded phone call at 1 o'clock in the morning, and you have a look at the environment, and what do you need to look at over the last hour? Usually that's kind of like the time span you'd look at. But who tells you what's normal and what's not normal? I mean, yes, of course, if you look at the environment every single day, you'll understand what's normal, what's not normal. And that works fine for 1, 2, 5, 10 instances and a couple of small environments. But once you start going over that complexity and over that level, purely just looking at something and understanding where it goes wrong only really works when the lights are out, right? So the box has crashed, or the service is no longer running, or something along those lines, where it's really, really obvious. In a lot of other cases, it is not that obvious, right? And if we take the conversation back to the database layer, then with that in mind, we need to be able to correlate queries itself, the query behavior, against all of the other data points that we collect, whether that's from the system stack, from the infrastructure, or whether that's from the app stack, and really start correlating those queries against what we see in the other metrics that we collect to understand where is something, and to be able to isolate what's potentially unusual behavior. Like we all have stuff in our environment where a query is pretty damn slow, and we know that. It's that one sign up query that just isn't working really well, and we haven't really gotten the time to look at it in much more detail. It works fine. It's not the greatest, and it runs about 500 times a day. So we're okay. It's not that bad. But if I look at it and it suddenly has run 20, 25, 30,000 times in an hour, then I know that something isn't quite right. Now, it might be okay, and we've just gotten really successful overnight, and instead of getting 500 signups a day, we've now gotten 25,000 in an hour. That's all great, but I still need to have the ability to understand that increase is unusual, right? And I also got to be able to really look at the individual query performance in itself, and looking at execution plans and things like that, and really understand, are we doing full table scans? Are we, maybe that query hasn't been constructed very well, and things like that, in order to understand where I need to again focus my attention on, in order to get to a quicker resolution time, in order to essentially ensure that the whatever service that I've gotten that call at 1 o'clock at is back up and running as quickly as I humanly possibly can. Because we all know that the longer the service has an outage, the bigger the potential damage is to, whether that's the bottom line, the brand's image, the overall customer experience, or internally, whether there's other tools that are connected to that service that would require our service to be up. So we know that the sooner we can get to the root cause analysis and the sooner we can fix the problem, the better. Now that kind of brings us into the next area in terms of, well, now we've kind of put the fire out, so to speak, and we may have fixed the imminent doom that the problem and the phone call at 1 o'clock brought us. But now is the time to start looking at where can we potentially look at making our overall environment more performant. And we got to be able to have a pretty quick overview on what's going on, right? And I'm not talking necessarily about, are you 5 versions behind? That's in a lot of cases pretty self-explanatory, might not be the best option. And again, those things are relatively straightforward in a 1 instance, 2 instance, 5 instance environment. Where it gets a little bit challenging is when we start looking at a multitude of instances, different versions installed because of different requirements. Some libraries might not work well with some versions, and we've all been there. We got to have a way to pretty easily figure out what's going on and where do we have room for improvement. For example, very, very easy, straightforward ones. Where are we missing indexes? Things like that. Have we done all of the updates that we need to do? Have we looked at the configurations the way we should? And in some instances, especially with configurations, they can be very subjective. In some environments, we do need to configure instances in a certain way so that everything works and plays nicely together. And we know that, and we can look at that, and that's fine. But nevertheless, it's good to have a way to get a quick overview of, well, are you sure about that? This is what we generally consider best practice. And, well, is your environment different, essentially, right? But again, it shouldn't be reliant on someone's memory. It should be reliant on there is an overview and there's an easy way for us to have a look at these and understand how our environment is set up and how we configure it, what versions we're running, things like that. And equally, just plain and simple understand query syntax performance, right? So, are we doing a lot of full table scans? Are we doing a lot of, where clauses that aren't, running properly? We don't have any way of limiting the results in those, and so on and so forth, right? Again, in a lot of cases, the way we deploy or the way we develop, we make use of built-in libraries that auto-generate our queries, right? And I'm pretty sure I'm not the only one that has done that in the past. It's a fantastic way of making sure you have a unified way of query generation, and everything works well from a developer's perspective. It doesn't necessarily mean those tool sets and libraries generate the most efficient queries on the planet, right? And it's good practice to understand what the impact of those would be, and where there's room for improvement, especially in setups where there may or may not be a dedicated DBA or someone with years and years of experience available to go through these very granularly and understand what the potential performance impact would be, right? And then kind of build on that is the infrastructure input. I mean, again, any sort of changes in the infrastructure are going to ultimately, inevitably have an impact on everything above that stack, right? So if my CPU is pegged at 95% most of the time and I'm running at 100% memory utilization, well, to be fair, if that be the case, then you have bigger problems. But generally speaking, that's not a good thing, right? Usually things don't perform very well at the upper limit of what's possible. So understanding the infrastructure and the impact that it has on how everything performs from the database upwards is very important. And on being able to correlate that stuff against your query performance and understanding that, well, hang on a second, if I have a query that's probably my indexing is a bit rubbish, and I haven't done a majorly good job in writing that query, and as soon as my memory utilization hits 80%, that thing just gets stuck and it runs, and you run into deadlocks and all sorts of other really, really interesting scenarios. Being able to correlate those things is crucially important. Understanding how the infrastructure and, like I mentioned earlier on, the potential of throwing money at the problem can have an impact on your overall performance, and being able to pinpoint where you need to throw the money at, if there is a need indeed, that can save a lot of money. And obviously it can help with reducing time to resolution and just overall make sure that capacities are managed a little bit better and with more insight. And then kind of lastly, I'm going into like I said earlier on, it generally is the first step in the process, but I kind of purposely kind of put it at the end of this, because having the ability to know all of these things along the way, from an APM perspective, from a database performance perspective, into something that we all are very familiar with, which is essentially, the ability to deploy code with a level of confidence that you understand that if there is code deployed, you can describe the impact it has on the environment. And from a database perspective, those are really, the two main things to look at are the query performance pre and post deployment. That's a very easy one, and anything that's new, right? Understanding what is new in the environment is really important, because you may come across a query that was never there before, and suddenly it takes up 20 clock hours, and 80% of your time is spent on that one query, and that one query was never there until the last deployment. Having the ability to tie that back against a particular deployment or a particular code change gives everyone the ability to start the process of understanding and resolving those problems way before they become problems. Staging environments would be a good example for that, right? Deploying things in stage, and understanding the query behavior of a new deployment, and catching those queries, or whether it's rogue queries that potentially were left in, or something along those lines, and having the ability to catch that stuff before it goes and gets deployed is a big aspect, right? And helps and makes along to have a better customer experience, better user experience for anyone who uses the services or products that we create. So overall, these are kind of like the three areas, and I'm trying to tie in the time here so I'm not running over by too much. But overall, those are the three areas that, when I'm looking at it from a application monitoring perspective, where does APM generally leaves off in terms of there is a problem with the database, and APMs have varying levels of insight into database. So I'm generalizing a lot here. But whereas usually it leaves off in terms of there is a problem within the database aspect, how to tie that into what we really need in terms of full observability, right from the app stack down to the infrastructure, and that obviously includes databases, and not particularly from the infrastructure level into the database, or just from the application level, but really having a look at the overall holistic view on where do those things tie together, and how can I correlate the data to make sure that I understand where the root cause essentially is, and understand where do I need to focus my energy and time on in order to fix problems quicker, in order to have better performing applications, better performing services, and overall create a better experience for whoever our end consumers are, whether that's internally or externally. And that is pretty much the end of it. And we've got 3 minutes left.